Welcome back to the Data and AI Specialist track at PyCon AU 2025. I am so excited to see you all in this absolutely packed standing room only room. Now the next session in our schedule today is a wonderful person, a friend of mine, Vivek. And when we read Vivek's abstract, hearing a real world use case and some lessons from applying a lot of the tools and the technologies that we're excited about, we couldn't say no to this proposal. And so please give a very warm welcome to Vivek, who's speaking on a case study on building our first LLM feature, how to balance speed and quality. Take it away, Vivek.
Cool, 1 second, sorry, my laptop's just freezing a little bit. Great. Cool. Good morning, everyone. I'm Vivek. I'm the lead data scientist at Multitudes. I'll be speaking today about one of the first features that we built using LLMs and taking you through some of the top tips that I would kind of give myself if I was to rebuild this feature again, and also for any use cases that you have. Just a little bit on the AI hype. There's a lot of chat around, is it going to revolutionize the way we work? Canva recently said they insist that people use AI in their job interviews. Meta's planning to fire a bunch of content moderation people, so we'll see how that goes for them, which is problematic. On the other side, we also have companies that have kind of turned the clock back on a bunch of AI features. Klarna famously fired a bunch of their customer support staff, and then now have had to rehire a bunch of people back and taken a big step back on the use of AI. For us, what we really care about is, are we solving a real problem, or are we just kind of buying into the hype? And just to motivate this talk and the feature that we were building, I'll give it a little bit of context on what our business does. So we provide insights into collaboration and team health for software engineering teams. And one of the insights we've always provided are quantitative measures into the feedback that teams are giving to each other. So for example, are senior engineers carrying the burden of code review? What's the gap in participation on code review? And are people getting kind of the adequate amount of feedback that they need to receive? Now the problem with quantitative measures is they're only like a part of the puzzle, and you can kind of gamify them in different ways. And so one thing we've always been asked by our customers is, what's the quality of feedback that people are giving to each other in code review? So there's a genuine need on our end for the use case of it. And there's a lot of research on why the quality of feedback matters. So this is just a really 1-minute lit review on why feedback quality matters. But one is, within your organizations, your best performers typically get the worst feedback. And that just is kind of reinforcing, hey, you're doing great, don't worry about improving on anything. And it's not the best way to kind of make your best performers even better. The other thing within the context of code review specifically, better feedback and code review processes means that, one, you have higher quality code in production, fewer defects, and code that's more maintainable. And then the human outcomes paired with that, you have better learning opportunities, not only for seniors but also juniors, knowledge sharing, and an improved psychological safety on the team. All the papers you can kind of see there, and I'll share the slides after. And then one thing that was really important for us as a business was looking at how it impacts folks from marginalized communities. And one thing that we've always been really passionate about is, how do we kind of elevate everyone in a team and not kind of just highlight top performers. And a lot of work has also shown that, one, people from marginalized communities get less feedback overall, so they have less opportunities to grow, which means, as you can imagine what that leads to, they get less specific feedback, and so they can't take action on things, and there's also a lot of negative stereotyping. And I want to also call out a study that I just read recently from Peking University that shows that the perception of competency when someone thinks they've written code with AI is greatly exacerbated for women relative to men. And it kind of just shows that this feedback thing for marginalized communities is kind of only getting amplified and worse with the advent of AI coding tools. So that's why it matters, various different reasons. And why we couldn't build it before LLMs was, traditional NLP kind of sucked in terms of the quality of performance we needed to ship to users. And this is just some real life examples from a sample of code review comments that we had in our customer database, where something like, hey, you're killing it, or phew, nice to get rid of all the old code, looking good, gets classified as a threat. Toxicity is still quite high, and severe toxicity is really high. And it might look like, oh, like 87% or 51% is not too bad, but like if every second or fourth comment that your customers are seeing is being kind of predicted inaccurately, that breaks a lot of trust with your users. And we did a collaboration with the university, looked at classical machine learning models. We looked at BERT. We looked at some of the paid models out there from big tech companies, and we just weren't getting the requisite level of performance we need. And that value equation changed with some of the new NLP things coming out of LLMs. So we had a genuine use case, which was great. And this is what we built. We're also a startup, so we have to move very quickly, unfortunately. So we had 2 people, myself and Kevin, and we had a month to build it. And we built something that kind of looks like this, which shows feedback quality broken up into 2 dimensions. One is around the tone and sentiment, and another one is around the specificity of feedback that people receive. Both of those are kind of shown within research to have a link to the quality of feedback, because it's a very subjective thing in the first place. And you can kind of see we bucket it into those different categories, and then also this negative bucket, which I'll talk about more later on. The outcome was we've had a lot of enduring popularity, and so it's been about 3.5 months now that we've launched this feature in our app, and this week it was actually the most used feature, and within the 45 different metrics in our app, it remains in the top 5 continuously. So it's definitely a good thing that we built, and some little verbatim from customers around why they loved it. But we also had a bunch of feedback, which I'll come to in the end, around how we had to make some changes. So today I want to kind of talk about, 1, how we learn from experts up front to move quickly, 2, use the right tools, 3, building an evaluation system, and then 4, building with some guardrails. And some takeaways that you can kind of take back to your workplace throughout. So one thing that we did really well, I think, was having feedback from academia. We knew that we were building something that's going to have a lot of pushback from different communities, and it was kind of a spicy feature that we were releasing. And so we wanted to make sure our methods were grounded in research, and we weren't just shipping something kind of breaking rules and shipping things quickly without any evidence to support our claims. And so we have ongoing relationships with some various academics and different universities who gave us a bunch of feedback on our approach. Margaret Ann Story is a leading professor in developer productivity. Kelly's leads a research group on the human aspects of software engineering, does a lot of research into toxicity in online communities, especially on GitHub. And then Nathan Cassie did his PhD on emotion and sentiment mining and GitHub as well. So some great people to get feedback from. What this meant was that we could kind of do a targeted lit review and not spend hours doing research work, and we could just read the 3 or 4 papers that they recommend us, and also kind of validate and test our overall formulation and approach to solving this problem. The other thing from academia that I would say you should also do is read papers that are going to enable you to move quicker. And some things that we applied from some different papers were task atomization, and so that's breaking up the problem into multiple components, and using an LLM to solve one task and then using a different LLM to solve another task. That can greatly improve performance of what you're trying to do. And then symbol tuning, I'll talk about in a second, but it was also something that showed that you could improve performance quite substantially, and one of the tools that we were using allowed us to do it pretty easily as well. But I will also say, take advice from academics with a grain of salt. One thing that we got told within the research community is don't frame bad feedback as toxic or negative, frame it as destructive criticism. And that was kind of the nomenclature used in the research community. When we put that in front of users on Figma and said, hey, what would you feel if you saw this on the app? They were like, no, I don't want to be told by an AI that my feedback is destructive. So we decided to go with negative, and more on that in a sec. But essentially the takeaway here is have some ongoing relationships with academia and speak to them early, so you're not kind of having to revert your entire approach at the end. Symbol tuning is a really interesting technique when you're building with LLMs, and it essentially says that you can alias your output variables to something abstract away from your problem. So rather than kind of asking a model to classify something into highly specific, low specificity, or medium specificity, or minimal, ask it to classify into K1, K2, or in our case we said koala, dingo, crocodile, and monkey or something. I can't remember what it was. And it's shown to kind of improve classification task performance by 15%. And we kind of got this for free in one of the tools that we were using. And so that was just something we could apply straight away and hopefully just get some performance benefit as well. The other thing we did is talk to industry and got feedback from different communities. So being involved in like the MLOps community or this PyCon community, I just posted in a few different Slacks and asked people like, hey, this is the type of problem I'm solving. Like, what are some tools that you can recommend or use? And it was really valuable because one, our customers also told us how they've done similar things, but it also meant that we didn't have to spend a lot of our internal resource trying to invest or research things and spend weeks doing spikes. We kind of could just pick something that we would hope would work, and it turned out it did. And also they'll tell us where you can move quickly and where you can't, and we could test our approach with these people too. So this is kind of the general overall modeling approach we took, and we'll go into a bit more detail for different aspects of this in a sec, but one, we built an experimentation data set, and that was by manually just extracting data out of our database, and collapsing feedback into different units of feedback that we were going to classify. Then we labeled that experimental data set ourselves, and so we got about 1,000 different pieces of feedback and asked all the software engineers on our team to spend time labeling that data themselves, and that's our evaluation system, which I'll get to in a sec. And then we classified it using various different models, so we looked at 8 models, 3 or 4 different prompts, and multiple different tasks. And then we also thought quite carefully about how do we actually evaluate which measure of performance we're going to use to detect which model to use in the specific use cases that we have. And then finally, once we had an approach that was working quite well, we shipped it out to production, and that's what that last step is. So I want to talk about some of the tools that we use, and these are the tools that really helped us move quickly. So Gradio and Streamlit, we use them for data labeling. I'll show the data labeling app in a second. And Streamlit to do some post-experimentation analysis of the data that we had. The reason we use those two, one, I just used both of them during my PhD, so I could just write a Streamlit app really quickly, and so we had that internal capability. Weights and biases weave. It meant that we didn't have to provision our own infrastructure. They have a really generous free plan. We could run experiments. We weren't using massive data sets, so we weren't going to hit their limits in terms of pricing. And they're also a customer, which works well. And then BAML is one of the favorite tools, and I'll show some code from BAML in a second. But it's really what enabled us to move really quickly on the experimentation side with LLMs, because BAML handled the response schema for the different models that we were interacting with. And so what that meant is we could focus on experimentation rather than having to deal with things like model hallucinations or like, oh, this text format needs to be passed into something else. And there are a bunch of other benefits as well to BAML. The key takeaway here is look at your team, look at your resources, and leverage what you or your team already know, and talk to people around what you can do to move faster. And these tools were ones that we found were fantastic to help us move faster. I want to give a special shout out to BAML because they were really helpful in terms of helping us move quickly. And essentially, there's some code on like how it works. You define your prompt as a function, and you can define like typed inputs and outputs. So this isn't real. It's like a toy example of what we actually did. But essentially, you can define an enum where you say feedback type is good or bad. You specify the client, and then you write your prompt as a function, and you compile it through its Rust compiler into a Python client, and then essentially you just get a function that you can have in your Python script where you can run the analysis straight away, and you get a pedantic schema passable response. You can run unit tests, so you can quite quickly iterate on your prompts. It's lower latency because they do the schema passing locally rather than on the model side, unlike tool-based approaches, which Claude or OpenAI offer. It's also cloud and model agnostic. And one reason that was really important is Mistral was the best performing model for the tone and sentiment component of our feature, whereas Claude was the best performing in terms of the specificity side. The problem with Mistral was that it was really crap at producing output that was schema passable. And so, and it didn't have a tools API at that time, and so we were really struggling to get like JSON passable responses back. And using a tool like BAML manages all of that for us, and we can really fixate on the task at hand, which is classifying into the quality of feedback, not which one's giving me better performance in terms of JSON output. It's also more token efficient because using a tools API, they've got a fantastic article on this, but using a tools API uses more tokens than asking for typed responses through BAML. And also the team was just like really responsive. Anytime there was an error, they would reply on Discord like within like 20 minutes. They'd be like, hey, can you just, yeah, I'll jump on a call and show you how to fix this. So yeah, special shout out to them, and they helped us move really quickly. So those are things that I've kind of highlighted that help you move fast. This is the part where I'm going to say don't move fast, move slowly, and move carefully. And this is creating an evaluation system. And unfortunately, it's not the most fun part for your team, but it's really what separates, I think, like a good product from a bad product, and it saves you a lot of time downstream when you need to redo things. And it's creating an evaluation system, or evals. So just real quickly on what I mean when I say evals, they're evaluation systems, and it's essentially just an approach for measuring the performance of your AI and ML products. And what they help you do is guide your model and prompt choices, reveal kind of problems that you might have in your model. And one thing we found, for example, was excessive nitpicking was being identified as a reason for negative sentiment far too much. And that was because one of the reasons was we kind of over-explained it in the prompt, and having like an evaluation data set that we could then test across our customers meant that we were able to kind of modify that really quickly and then kind of ship with confidence. It also prevents you from bloating your prompt or overfitting your prompt to specific things from your customers. And this is something I've seen in other AI teams happen a lot, where they'll release an LLM feature and they'll say, oh, this didn't work. And so they'll go back and change the prompt and be like, okay, I fixed this one thing, but now you've broken like 50 other things. So you don't really know what your coverage is. So an eval system really helps you prevent that. So what we decided to do is build the ground truth with domain experts. We sell to software teams. We have software engineers on our team, so unfortunately that meant our team was the one doing the data labeling. But essentially, like if you're using LLMs, or you wouldn't use LLMs, but if you're, say, doing a healthcare application, you would use doctors or maybe nurses to support you in your data labeling. If you're doing surveying, using AI to help surveying land, you would use like land surveyors to do your data labeling. It has to be done with ground truth because they're the ones that can capture the different nuances in the underlying data that you're doing. So we built a little app where we kind of just surfaced data from our customers to our engineering team, and then they would classify it into different buckets, and that would give us a ground truth data set to work off. One thing that took a lot of back and forth was even just agreeing on like what is bad, what is good. And we looked at statistics like Cohen's kappa or inter-rater reliability statistics to make sure that we're able to establish like agreement. And we did that with a sample of only 30 data points first that everyone labeled together. And then once we were able to achieve agreement and alignment on how everyone labels, then we proceeded to tell everyone to go and label 1,000. But start ASAP, because trust me, it takes a lot of time to get people to do data labeling, and it's not fun. And I was probably chasing people up like every 3 or 4 days, like, hey, where are you at? How many have you done? And I said we needed 2,500, but we only got to 1,000. So yeah, definitely motivate people. The last thing is you've got now your models that you're experimenting with, you've got your ground truth data, and now you're running some experiments, but how do you actually decide what metrics you're going to choose your model choices based on? And so this is where, again, you kind of need to go back to your problem and your business case and talk to your users around what's important. For this feature for us, one thing that was really important for us was whenever we predict something is like negative, it should be negative. And the other thing was we shouldn't be predicting like positive things as negative and negative things as positive. And so some of the evaluation metrics we decided to configure in our experiments was extreme misclassification, which tells me how often is a model predicting like the complete opposite class, because there's an ordinality from negative, neutral to positive, and then specificity there's the same, like minimal, unspecific, neutral, specific, highly specific. So how often is that extreme misclassification happening? And then specifically for the negative feedback, how often are we actually getting the like precision specifically for that class? Because we don't really care about the neutral ones, because the users, when they get told that something's negative, they're going to feel much more emotive about it. And this will be different for every use case that you have. And so again, whatever AI or ML problem you're solving, your evaluation metrics should reflect kind of the experience you want your end user experience to have. So design the measures based on that. The other thing evals are really helpful is in reducing your experimental overhead. You can kind of generate a smaller eval dataset or not have one at all and have infinite numbers of parameters to use and agonize over like, oh, there's a new AI model, there's a new experiment, I want to experiment with this prompt and this prompt. Having a ground truth data set that you can look at and say, okay, I'm happy and confident to ship this into production means that you're able to limit the experimentation surface area and run less experiments as well. And so what that meant for us is something that kind of looks like this, where the ground truth distribution of feedback looked like that at the bottom, and then when we kind of built the approach out on Streamlit, we had something that looked pretty good, and we're like, okay, like we don't need to run more experiments. We think we can probably ship this to our customers. One thing we noticed from that was different models perform better for different tasks. Like I said earlier, with like the specificity models, we had kind of one of the Anthropic models that performed best. With the bot detection models, we had an AWS model that performed the best. And then with the tone and sentiment, we had like a French company, Mistral, their model performed the best. We had very few examples of toxic and negative feedback within our ground truth data set. And so less than 10 examples in 1,000. And so one thing we're doing now is working with the University of Auckland to mine more toxic conversations so that we're able to like better predict that. And then also it wasn't great at non-English feedback, and we have a bunch of customers in Latin America, and it was just like predicting things that were in a different language not that well, and so we had to make some changes based on that. So the last thing is on guardrails. Cost is always a big thing with building AI products. And one thing you'll often hear is like the new model's cheaper based on input and output token cost. But what we really care about, and what I would say is often important to think about, is the cost per task and looking at P99. And this is kind of trying to highlight why. So DeepSeek as a model is cheaper than Anthropic, about 3 times cheaper for an output token per 1,000 token cost. But because it's a reasoning model, it's quite verbose in its output. For the task that we were giving it, it was actually like pretty much the same, slightly more expensive than the Anthropic models. And so rather than looking at the token cost, input-output token cost on AWS or Bedrock, actually look at your specific task that you're doing and budget for P99. The reason you want to budget for P99, it means that you have a lot of room to kind of explode your context window as you want to improve performance as well. And so you're not going to get kind of thrown into like, oh, why is this cost so high? Because you've kind of budgeted that in as well. So that's why we looked at P99 and also said to look at tasks. Consider AI ethics. This is really important. So we wanted to make sure we had diversity in the team that was labeling this data as well. And one thing we found was that within even those less than 10 negative samples, like women were more likely to label feedback as negative than men on the team. And that meant that we kind of updated the ground truth that we were basing our truth on, based on kind of making sure that we're representing like what the women were saying more than what the men were saying. And we wouldn't have seen that if we didn't ask people to label the data set ourselves. And then lastly, transparency. We're very transparent with how we build our features, to the point our docs have pretty much everything. We don't obviously share the model choices and prompts, but fairly like lots of user research and the approach. And we got lots of feedback. Some was great, some not so great. And like I said about the negative feedback, one thing people didn't like was that a model was calling their feedback negative. And so just from like a UX design perspective, we decided to update that to needs attention. Under the hood, nothing's different. But going from the researchers who told us to say destructive criticism to us like settling on negative to now what we have is needs attention was just some feedback that we got really quickly, and we were able to ship that out. Some other one big piece of feedback where people didn't know what good or bad looked like, and so we had to do some internal analysis to figure out like what are some good benchmarks so people can kind of, like having an LGTM in a code review is not a bad thing, but if you've got 95% of LGTMs of all your code review, that's probably something you should talk about. And what we did is we clustered some of the high-performing teams based on different metrics in our data set, and identified like what their feedback distribution patterns were, and kind of came up with some benchmarks based on that, and that's what you're seeing in those green bands. And then the other one was adding some insights into how they can take action on this data as well. And so that all happened within kind of the next month of releasing this feature, which was super exciting for us. We've never had so much feedback come in for a feature that we've released, so that was pretty cool. And one key takeaway there was it doesn't matter too much on like the thing you release, because we've kind of built the brand equity with our customers to know, so they think that we're thoughtful and they can trust us. And so how we respond was kind of more important. And yeah, just like, adding that needs attention thing did a lot of goodwill for various different organizations. So yeah, just to summarize the 4 different tips for building features well, from my experience. 1, learn from experts up front. They'll tell you where you should look for literature and also what things and tools you can use. Secondly, use the right tools. Rely on your team's expertise and your own expertise to move quickly. 3, this is where you slow down and create an evaluation system that reflects whatever your problem is, and then build with some guardrails in place. And that's, the talk. Thank you.
Would you know it? I reckon that was practiced so many times. We are bang on time. So a big round of applause and a big thank you from the conference.
No questions.